It's just more of the what I want you to focus on. Here we go. Grab your exercise book. We're going to write the rules. So on one side, I want you to write f of x for the function that you could have. And then on the other side, it is the derivative. Now, the functions that you have been familiar with is something like when you have an x to the power of n function, so a power function. We know that the derivative for this rule, what was the derivative for x to the power of n again? Very good. This is the power rule, so I'm just going to pull all the way down there. So you got the power rule, which is n times x to the power of n minus 1. I'm going to write on the side, this is called the power rule. So you use the power rule when you have a polynomial function. What we've learnt so far is that you can have n being positive or negative or fractional. Okay? Next one, which I haven't shown anything else but power rule, right? Here's your next few rules that I want you to copy down. You can have e to the x. You can have log e to the x. You can have sine of x. You can have cos of x. And you can have tan of x. Derivative for each one. E to the x, the derivative of it is the same as it is. This is 1 on x. And then this is cos of x. Negative sine of x. And the second squared of x. For those who don't know what that is, it's 1 over cos squared of x. And for those who don't know what that means, it's 1 over the cos of x all squared. Okay? So, as you're copying them, that's what I want you to have down because that's what we're going to be using. So remember, power rule is only one of the many rules that you had. So remember, these are all shortcuts. Instead of doing first principles, okay, 17a, instead of doing 17a, if you have any of these functions, these are the rules that they've figured out for you, and you don't need to know the proofs for them. You just need to know how to use them. That's what it is. The meaning is to find the derivative. Okay, so you're trying to find, you're differentiating, that's the verb. You're finding the derivative, which is the noun, and that is your gradient function. So the gradient of any point on a curve. Okay, gradient of a tangent line at any point on a curve, and you only need 1 point. That's what this is. Okay, so I want you to copy that down. Make sure you have 1, 2, 3, 4, 5, 6. There are 6 rules that I'm going to expect you to all know because eventually once I get you really good at chain rule, I am going to ask you a question like log e of x squared, and I expect that you can find the derivative of that using chain rule in your head. Okay, that's the goal. Right now, we're going to practice with the rules, so please copy down the rules. Put your power rule there, exponential rule or function, logarithmic function, sine function, cos function. Notice that there is a negative. Most students forget that negative there. There's a negative. And then tan is sec squared, or 1 over cos squared of x, or 1 of cos of x all squared. Okay? There will be 3 rules that you will have to learn for next year. On top of that, these are like your methods. So you got chain rule, product rule, and quotient rule. I'm going to be focusing this year with you on chain and product. Once you get those 2 well, then you'll find that doing quotient will be pretty easy next year. Okay, but normally these are your year 12 component, and you generally only learn this section. That's all you need. Okay, but we're now making sure that you know your chain rule and product rule because that's a very common skill that you must know in year 12, and seeing it early in year 11 makes it easier for next year. Okay, let's go back to chain rule. What was the rule that I gave to you For the chain rule again, what was a chain rule? Delta y? Good. Delta y over delta u. Is equal to? Very good. That's your chain rule. If you've got those formulas down, that's what I want you to take in, because I'm going to do some examples where I'm going to mix it around and you can see how I'm using chain rule to find the derivatives of each one. Okay, now, in your text, and the reason why I want you to copy it the way I teach you, because your textbooks will show you a different formula. So I'll give you an example. E to the x in your textbook, they will normally do something like this. They'll do f of x is equal to e to the kx, and they'll write the derivative is equal to k times e to the kx. The reason why I have an issue with this formula, it's not that it's wrong, it's that they omit the chain rule. And so I find that the common mistakes in year 12 that students have is when the examiners don't give you to the power of x, but instead they'll give you something like e to the, so y equals e to the power of 2x squared minus x cubed, and students get this wrong. Okay, or even if they made it easier and they just chuck that, students will question 2 is the k, so they're like, okay, I know how to do the k, so 2 goes to the front, but what happens with the x squared? They're not sure. Okay, so they'll treat it just as it is, and that shows me they don't understand chain rule, which is why I want you to understand that this is the derivative and they're using chain rule to get that formula there, and I'm going to show you how that occurs. Okay, so that's why I don't want you to follow the textbook, and I want you to do it the way I'm teaching you. Okay, all right, let's go through some basic examples again. Let's go back to this. This is what you were doing last session with the worksheet, so hopefully you still have the worksheet. If you don't, it's digitally on OneNote for you. All right, here we go. Let's pick a few. I'm going to do, let's say, yeah, I'm going to do H is a good one. And I'm also going to do G. Okay, so let's do G and H. Let's do H first, just because it looks a bit nicer. Y is equal to bracket 5x squared minus 1 to the power of 7. Okay, so we don't know how to do the derivative of something like this. Okay, we don't have a rule for that. All we have in your 6 rules that I just gave you, none of it has more than one term and the power of. The only thing we have here is something, so just one variable to the power of n. We don't have that. This question is more than one variable. Yep.
Quick question. Those 6 things, are they all part of power rule?
No. So each one, yeah. So this one is power rule just for that. This is an exponential. We don't give it a name. We just say it's exponential function. Yeah. So this is a power rule for power functions. But if we would do this question here, one of the things I taught you in the last session was to make this problem simple or simpler, which is what chain rule is trying to do. So we didn't know how to do it 5x squared minus 1 to the power of 7, but we do know how to do it if it was, say, u to the power of 7. That was easier to do. Okay, so if we could change that problem to something like this, we know how to differentiate. So chain rule says, all right, well, why don't we replace that? Why don't we call that u? And if we called that u, that now becomes u is equal to 5x squared minus 1. So that means I'm replacing that entire equation inside the brackets. That now becomes u. So that's u to the power of 7. The beauty of doing that is that I can find the derivative now, delta y, not delta x anymore, but this is delta u. I can find the derivative of this because it's easier. It's just u to the power of 7. So using my power rule, so you can go back to your power rule, your 6 rules here. This is your power rule, one variable to the power of n. It should then give you 7, which is your n value, times u to the power of 7 minus 1, which gives you 7u to the power of 6. Okay, so that we know how to do. Chain rule, remember the chain rule was you're trying to find delta y, delta x. They said, yeah, you can do that if you do delta y delta u times delta u delta x. That's the chain rule. Okay. What I have now is I've already got delta y delta u. I've got this one. I now just need to find the derivative of a function where I have u and I have an x. So u in terms of x. Now, where in my question have I got that? It's right here. I said u is equal to 5x squared minus 1, and that was a hypothetical layout. Sometimes it works, sometimes it doesn't. These questions will work out. Okay, so I'm going to say, if I let u equal to 5x squared minus 1, and then I say, all right, find delta u, delta x. Then again, we can see that this is a power function, and that's a constant. We can find the derivative. What is the derivative of 5x squared? Say it again. 10x, very good. Okay, so again, remember the 5 stays the same, so it's still 5 times, and you're finding just the derivative of x squared. And we know that that is 2x, and then minus the derivative of 1 is 0. So here we go, you get 10x. Now I have delta u, delta x as well, so putting them together to find my delta y, delta x, which is my derivative, it must then be 7u to the power of 6 times 10x. Put it together, that gives you 70x u to the power of 6. That's not my answer though. Why? Matt. Very good. Your notation here is change in y and the change of x, or with respect to x. That's not x. So you need to bring it back and say, well, let's convert it. And remember, we said u, the letter u, was equal to 5x squared minus 1. So I can rewrite this whole entire thing and say it's 70 times x times 5x squared minus 1. Leave your answer like this. Do not expand. They want simplified answers. Yep. Oh, thank you. Very good. Okay. So leave your answers as a factorized answer. In year 12, they always want everything factorized. That's why you spent a lot of time from year 8, essentially, all the way to year 10, practicing factorizing skills. Okay? So that's my answer there. That's how you would do it. If you do it on your CAS, they may have this answer, or they might have had an expanded version. You can expand them both, and they should be the same solution. But that's how you do this. Now, the question is, how do you do this faster? As you do them, you start to pick up the pattern. You see, when I do this in my head, I'm actually just already deriving what I can see that's to the power of 7. And the first thing I'm thinking about is, like, oh yeah, I know how to do something to the power of 7. And that would just be 7u6. So in my mind, I have 7u6 multiplied 2, and I need to find the derivative of this. Most of you can now actually find the derivative of this without writing it down. You can then say, well, that's 10x. So 10x times 7u6, that's the first thing I'll write. So I don't have to do all these steps here, and I'll be writing that as my first step. Year 12, they do not expect you to write this at all. Okay? They just expect that you got your function, and that's your first step. That is the expectation. Okay? But at year 12, if you've never seen chain rule, it is tricky. But if you practice this year, by the time we get to the end of the year, you should be able to do this step, and you take it on from there. So it should only take 3 steps to complete, or if not 2. Okay? Let's do another one. I'm going to do another one, and I'm going to do it same idea. So we're going to do H. Let's do H. Oh, sorry, I did H already. Let's do G. G now has a fraction in it. 2x cubed minus x to the power of 2/3. Okay, so we're going to do it the way I do it in my mind. So let's try to do it in my mind. So same thing. This is what I'm seeing. I'm picturing what is the issue to this question. We don't know how to do this. This is what I want to get rid of. So in my mind, I'm already finding the derivative of 2x cubed minus x. So do that in your head. What's the derivative of 2x cubed? What is that? Derivative of 2x cubed. 6x squared. Very good. And then derivative of minus x. Minus 1. So that's, in my mind, that's what I'm already doing, or I'm writing that down already. So delta y, delta x, in my first step, I've got 6x squared minus 1 multiplied to, Now I figure out, I pretend as if this never existed. And it's just something to the power of 2/3. That's what I'm picturing. So in my mind, I said, all right, what's the derivative of that? So if we do the derivative of this, this would be 2/3. So n is 2/3 times u to the power of 2/3 minus 1. You can do that in your mind. 2/3 minus 1 is negative 1/3. And that is your first step. See what I'm doing? I'm bypassing all those steps over here. And that's how I do it instantly. So when I ask you these questions, you're going to be doing that in your mind. You're differentiating the inside and you're differentiating the function overall. Okay, and you can apply that for logs and sines and all that. But right now, I'm just going to get you to practice the chain rule from that worksheet I gave to you. Okay, so from here, we haven't finished our answers. U, remember the letter U is actually just that replacement. So it's 2/3. U should have been 2x cubed minus x to the power of negative 1/3 multiplied to 6x squared minus 1. Remember, you don't leave your answers with negative powers. So here we go. It should be 2 times 6x squared minus 1 all over 3 bracket 2x cubed minus x to the power of 1/3. Okay, so if you write it like this, that's already a mark. I probably would have wrote it as a cube root. Okay, so cube root of 2x cubed minus x. Okay, so have a think about what I just did just then. That flips, so it goes to the denominator. That stays in the numerator, so 2 times 6x squared minus 1. And then 3 times that with the negative power becomes positive power. Yes, Erin? Question 5 of the worksheet. Yep, let's have a look at question 5. All right. Let's do question 5 together. So same thing, we're going to do chain rule again. Here we go. Ooh. Let's move this over here. Shh. Thank you. All right, let's do this one. So same thing, you want to have a go first before I write out the answers. But here we go, we've got the function y is equal to x squared plus 3x squared. So same thing again, I would do the derivative of the inside because I know this is what I'm replacing. So if I write out the working solution, I'm saying let u equal to x squared plus 3x. Delta u, delta x should be 2x plus 3. That means this is now y is equal to u squared because I'm replacing that entire thing with a u. So delta y, delta u should be 2u. Okay, or you can replace the letter u if you want to at this step. And we know that's 2 times x squared plus 3x.
You're literally wrong.
Me? Oh.
Why just skip all the steps?
So from here, now we're going to find the derivative. So together, chain rule says delta y delta x equals delta y delta u times delta u delta x. So let's put it together. We now get 2 times x squared plus 3x multiplied to delta u delta x, which is 2x plus 3. And you can leave it there. You don't have to expand or anything. This is your derivative or gradient function. What? This one? Yeah? Ah. Okay, yeah, makes sense. And then from here, it says where x equals negative 2, they want you to find the gradient. So here, this is how you should write it. At x equals negative 2, delta y delta x, which is the gradient will equal to 2 times negative 2 squared plus 3 times negative 2, 2 times negative 2, and then plus 3. So assuming that you do all that correctly, 2, 4, minus 6, negative 4, plus 3. That should be 2 times negative 2 times negative 1, and that gives you 4. So gradient is 4 at that point. Okay, so don't forget the purpose of the derivative. So whatever that function looks like, we just know the gradient of the tangent is 4. M is 4 at the moment. Yep. I wouldn't do it. I would write out at the bottom, I would say, therefore, gradient is 4. The reason why I don't use M is because we haven't defined what M is. And they didn't talk about a tangent line. So I wouldn't just write M with a tangent line. If they said a tangent line, I would have said tangent line y equals mx plus c. And then when I get the point, I would say then M equals 4. So I would say something like delta y delta x equals 4 equals M. And then I would replace it. But I wouldn't just use M straight away. Yeah. All right. Question. Yeah. F inverse negative 2. Oh, yeah, F dash. Yep. So in this question here, because they use y, I stuck with y. But you can take a step here and you could say, let y equal to f of x. And then you could write f dash of x. And that's okay. But you'd have to define it if it's not part of the question. Yeah.
And then if you do it in that notation, we need to write it like y equal at x equals to wait, go to that. You still need to write that.
Oh, here, the replacement for this one would be f dash of negative 2. Yep. Yep. Did I answer that right? Yeah. You can then substitute it into the equation. Yeah. Okay, so that's how you do question 5 there. But that's what I want you to do right now. Just to practice that, once you've got a feeling of chain rule, then I'm going to start giving you this sheet so that we can practice with the 6 rules that you've got. Okay? Faster chain rule?
Yeah.
What's your faster chain rule? Which step did you skip?
It's called a calculator. You don't have to write you just do it.
No, you don't. I'm doing it because you guys are still learning, so I'm putting it out so you can see what I'm doing.
But is it going to be taught this year?
Yeah. So in order for you to do it in your head, you have to not do this step. Otherwise, too much to think about. I don't know about wasted time. When you have to do a double chain rule, it's better to be careful.
Even double chain rule, you don't do it.
Well, you don't, but probably most people do. I'm teaching to the general population here.